All right, this is Honors Algebra 2 Pre-Calculus. We're doing 6.2 in Algebra 2, which is the second video, continuously compounded interest. So recall that in 6.2, we learned a formula for compound interest. In fact, we even made a calculator program for it, right? If you go to program, we have compint, right? So where n is the number of times that interest is compounded annually, right? So that's this n that we see in the formula here and here, right? So we've also seen that this formula, 1 plus 1 over n raised to the n, for very big n approximates e, right? In fact, for infinitely large n, it actually is the definition of e if you were able to pick an infinitely large number for n. So continuously compounded interest means that n approaches infinity. It means that you are compounding every second, every millisecond, every fraction of a millisecond, interest is being compounded. N is such a big number, n is infinitely large, that essentially what ends up happening is we're able to take this formula that we learned, and through a little bit of math shenanigans that you're not quite ready to know at this stage of the game, we can combine this with the knowledge of what E is to get this formula, A equals PERT. So for continuously compounded interest, we use the formula A equals PE to the RT. P is still the principal, meaning the starting amount, right? A is the amount at time t. R is still the rate at which interest is compounded. The difference is that we don't end up needing that n because, again, in this situation, continuously compounded interest means n is approaching an infinite value. So we're going to go ahead and use A equals PERT. It's PE to the RT, but I always remember it as PERT. For the next several set of problems, again, you'll know you're using this formula, not the other one, because you're going to hear the word continuously compounding or continuous compounding. All right, so example 4. Interest is compounded continuously on an account. How long will it take for the investment to triple at a 12% rate? Okay, so I know that P is the money I invest, right? That's not I invest. Invest. Come on, brain. Invest. I don't know, people. I don't know. My brain's tired. So it's the money I invest, right? When we want to know how long it will take my money to triple, what they're saying is when is my amount equal to 3 times the amount that I invested, right? Since I'm being asked when, the unknown here is t, and I'm told that the interest rate is 12. So here's what I know. A equals PE to the RT. I know that my A is supposed to be triple my starting amount, right? I know that the R is supposed to be a 0.12, and I don't know time. Since I was asked when, time is my unknown, right? Time is the thing that I'm going to have to find. So I'm going to go ahead and start solving for t. So the first thing I'm going to do, there's no subtraction or addition, but there is division or multiplication to solve for t. I could divide both sides by p, and p is going to disappear. So I'm going to get 3 equals e to the 0.12t. Now I want to solve for the exponent. The only way to do that is to rewrite this in log form. So rewrite as a log, right? When I rewrite this as a logarithm, it's going to be log base e, right? So log base e. So recall that natural log is the same as log base e. We don't really write log base e. So essentially what's going to happen if I rewrite this in log form is log base e, so e to the 0.12t should give me the stuff inside the log. So natural log of 3 is 0.12t. So if I divide both sides, and keep in mind natural log of 3 is a number, if I divide both sides by 0.12, I get that t is natural log of 3, which I'll put in my calculator, divided by a 0.12. So the time will be natural log of 3 divided by 0.12, and I get that it's going to take 9.155 years. That's how long it'll take my investment to triple, okay? So again, interest is compounded continuously. How long will it take my investment to triple? That's asking about the time. Okay, let's go ahead and try a P4. Same idea, pause me if you want. So we want to know how long it'll take your investment to double, right? So we know that it's A equals PE to the RT. Well, if I want my investment to double, that would be double the initial amount, right? So 2P is PE to the 0.07T. Oh, sorry, I know what P is, my bad. They did you a solid, they told you 1,000. So actually you can say 2,000 equals 1,000 e to the 0.07t, although it won't matter. So here P is 1,000, 2P is 2,000. But you can see that just like we saw in the last time, I'm going to divide by that 1,000 anyway. I'm going to divide by the 2P, or by the P rather anyway. So it's just going to end up being a 2. It wouldn't have mattered if you didn't know what P was because you just divide. And you're going to get 2 equals e to the 0.07t When I rewrite as a log, it's going to be the natural log of 2 equals 0.07t. Now, interesting side note, the other way to think about this other than rewriting is you can actually take the natural log of both sides. Because remember that if you do the log base b of b to the x, this cancels and you just get x. So if you think about it that way, I could have said natural log of 2 equals the natural log of e to the 0.07t. Well, the natural log of e cancels, and I get natural log of 2 equals 0.07t. And that might be an easier way to think about it. Either way you choose to think about it, right, I'm going to then type in natural log of 2 and divide it by 0.07 to get my t value. So natural log of 2 divided by 0.07, I get that it's going to take 9.902 years to double. Okay? All right, so let's try an E5. Interest is compounded continuously on an account. You invest $500, that's your principal, with a 10% interest rate, so that's 0.1. And you're told the time is 20 years. So here you're trying to find the amount, right? The unknown is not the time. So A equals P E to the 0.1 times 20, right? And that's exactly what I'm going to type in my calculator, right? So I'm going to do P, which is 500, right? Second natural log is E, and then I'm going to do 0.1 times a 20 and hit enter. And I'm going to get, this is approximately, now this is one of those few times that you can go to two places because it's money, right? So for money, I would suggest that you go to two places, right? So it's money, right? You're going to do money to cents, right? Not to the extra place, okay? That's one of the few times that it's okay not to do extra. All right. Go ahead and try P5, right? So you invest $200, that's your principal, the starting amount, at an interest rate that is 8%, so that's 0.08, right? And your time is 10 years. So we want the amount to be P E to the R T, right? And so then we're just going to get an approximate amount. So if you want, you can either do second enter or you can type the whole thing from scratch. Doesn't matter to me. So second natural log, 0.08 times 10. All right, and we get that that's $445 and 10 or 11 cents, depending on if you round or truncate. Make sure you put a dollar sign. Okay, cool. So before we move on, let's do a couple tips about money management. This is not strictly a math class topic, so if you want to stop listening to me, this is the last thing I'm going to talk about in this video before we do a separate video for the last topic in 6.6. So some tips about money management. When you talk about investing your money, time is the most decisive factor in the future balance that you're going to have in your money, okay? So what I mean by that is invest early. If you're in college and you're working really hard and trying to save every dime and just trying to get by with student loans or whatever else, if you can squirrel away $20 a month into a savings account at 18, if you keep doing that every month, if you say, I'm going to put aside this $20, I'm going to put it in an account that I'm not going to touch and it's going to be protected and safe, and I'm going to save and invest, either save or invest this money specifically, you will, but if you can invest it in some sort of like start a retirement account when you are 18 years old, right? Start a retirement account that you put $20 a month in, starting at 18. And I promise you that the position you will be in when you are 40 or 50 or 60 is a much better position than people that did not do that. If you invest small amounts of money early, it has a much more drastic impact than investing large amounts of money later. That's not to say that if you suddenly find yourself with millions to invest, that's not awesome and wow, congrats, you won the lottery or whatever. But putting small amounts of money in an investment early in your life and continuing to do that is going to be the decisive factor in your financial stability later in life. Be smart about it. Second thing, when you get your paychecks, use the 50-30-20 rule. So 50% of your income should go to things like living expenses, rent, mortgage, groceries, transportation, bills, right? Making sure that you have heat and water and gas and whatever else you need, etc. Okay? 30% of your income should go to wants and lifestyle choices, things like fun and entertainment and dining out, which I get is all kind of weird right now in the middle of a pandemic, but 30% should go to stuff that makes your life happier. Because if you're not living a quality life, if you can't, and maybe that 30% is a little bit lower sometimes if you know you're saving for other things, but 30% of your money should go to sort of the more frivolous things that make your life better, even if they're not necessities. And then 20% of your income should go towards debt payment and savings, right? Obviously, if you can shave some of that money off the 50 and the 30, like if you find a really affordable place to live and you like it and you're happy and your rent is better than somewhere else you might live, that's great. And you can put more money in that 20% for savings and investment, whatever. But really, if you follow this as a basic guideline, you're going to be in a much better spot than most people. Notice that this doesn't involve you depriving yourself of all of the things you love. There's a good amount of money in that. Like a good percentage of the money you're making goes to things that make your life more enjoyable. Maybe you're somebody who really likes to shop. Maybe you're somebody who really likes to go to movies, whatever. Maybe you like to eat dinner at a fancy restaurant or whatever. But if you are mindful of the way you're putting your money in places, you're going to live a much easier life later, right? Sometimes putting in the time early to establish these good habits makes life a lot easier later. Last thing, have a separate savings account. So have a checking account and have a savings account. Use your checking account for normal spending, like your paycheck goes into your checking account and you use it for normal spending and bills and everything else. Don't use your savings account for spending. Transfer some money in there every single month. So if you get a paycheck, transfer some amount of that paycheck, specifically, hopefully 20% of that paycheck, unless you're also paying down some other debts, right? Put that in your savings and don't touch it, right? Keep it there, and it's your safety net in an emergency. Ideally, you don't have to touch it, but you're going to have to at some point, right? If you get tons of safety net, if your safety net is really big because you haven't had to touch your savings account for a long time, then you can take some of that safety net and invest it, right? And if you invest early and you invest reliably, you'll be surprised how big the turnout is later in your life. But you should always have a safety net. Cars break down, people get sick, jobs get lost. We always hope for the best, but you need to plan for the worst, okay? So again, not a math video, just a video about some basics in terms of money management and moving forward as you enter adulthood.